Good morning everyone. Today we are here to discuss the atomic nucleus, which is the one of the fundamental part of the atom. In this lecture we will discuss about the component of the atom, then we move to the atomic nucleus, and after that you will understand what is the composition of that nucleus. Now first of all, let me start. There is two part of the atom. Let us consider this is the atom is look like this have two parts. One is the electron, and another one is the nucleus, which is the nucleus. We can say a atom is consist of two part. One is electron and another is nucleus, in which nucleus is the central part of, which is shown by a small part, which is considered of the whole mass of the mass of the atom, and the electrons revolve around this nucleus, these central parts. Now move to the composition of the nucleus. Now nucleus have, if we consider this nucleus consists of two components. One is the proton and another one is the neutron. The whole mass of the atom is considered to be found in this nucleus part. This is known as nucleus. The proton is given by positive charge and neutron have no charge. So in this chapter we will just discuss about, can you find if there is the proton have positive charge and neutron have no charge, then which force bind them? If we see, if there is proton, there should be a repulsion between them. But if repulsion is there, electrostatic force, due to electrostatic force there is a repulsion, then there should be the breakup of this nucleus, or these proton will move apart. But in this nucleus the proton does not move apart. It means there is another force which bind them, which is the strong nuclear force, which bind the nucleus, which is the strongest force of the nature. Here is, we discuss two force. One is the strong nuclear force, and another one is the electrostatic force. The strong nuclear force, when the strong nucleus comes into play, which bind them the nucleons in the nucleus. This force is always applicable in charged particle as well as charged and non-charged particle, means the neutron as well as in between the proton. So here we will discuss the difference between the strong nuclear force and the weak electrostatic force. Electrostatic force, what is the electrostatic force? Electrostatic force is the force between the charged particle according to the Coulomb law. The strong electrostatic force is given by the 1 by 4 pi epsilon naught q1 q2 by r square, where if we consider two charge, this is charge q1, this is q2. If there is a distance between r, then electrostatic force is given by 1 by 4 pi epsilon naught of the product of the charges and the inversely proportional to the square of the distance between them. But question come, what is the epsilon naught? Epsilon naught is the permittivity of the free space. If there is a material medium, then the permittivity changes to that material. So there is the electrostatic force. In the strong nuclear force basically depends upon only the proton and neutron spins. It does not depends upon the charges. So this is the it is the forces which responsible for the binding of the nucleus. If we move exactly the move to the isotopes and the nuclear stability. How the nuclear stability take place and what are the isotopes? Isotopes, basically the isotopes is known as, what are the isotopes? What are the isotopes? Isotopes Isotopes are the nucleus in which say the nucleus which have same number of same atomic number but different mass number are known as the isotope. For consideration, 6 carbon 12 is the nucleus which have carbon nucleus which have 6 atomic number. This is the atomic number is written here. If you write any atom, this nucleus can be represented as where Z is the atomic number and A is the atomic mass number. Atomic mass number is given as the sum of the neutron plus proton. Sum of the neutron plus proton is known as the atomic mass number, and the number of proton is known as the atomic number, that is Z. Here if you write 6 carbon and 13 carbon and 14 carbon, they all atoms have same number of the same atomic number but different mass number, so they are the isotopes. Now come point second, what are the isotones? Isotones, the nucleus, the atoms which have the same number of the neutrons but nucleus have same number of neutrons. For example, 6 carbon 14 nitrogen 7, both have the same number of the neutron which is 777. So these are the isotones. Now come to the third, that is isobars. The nuclei which have same number of atomic mass number but different number of the atomic number. So same atomic mass but different atomic number. For example, if we see 13 carbon 6 and 13 nitrogen 7, then both nuclei have same mass number but different atomic number, so these are known as the isobars. If we move to the nuclei, as we consider, the nucleus is the compact part which is the smallest part. If the size of the nucleus increase too large, what happen? If we consider the nucleus in which we found that more number of nucleons, what happened this nucleus? First let us see what happened to this nucleus if there is a more number of the nucleons. This is the atomic nucleus. Let us consider there is proton, and proton. There is increase of the proton. So due to increase of the proton and the size increasing the size of this nucleus, there is the increase in the electrostatic force. Due to electrostatic force, there is the repulsion force comes into play, which can be affected and maybe more than the strong nuclear force. So at this case, the nucleus the proton repel with each other, due to which the proton move outside from the nucleus. So in case we see the if we see the uranium 235, we see that 92 uranium 235 we see that there is 92 proton. Due to this, the size of the nucleus is increased, and due to which if the size of the nucleus is increased and there is the repulsion increase, electrostatic force increase. If electrostatic force is increasing, that's why there is the tunneling of the proton from the nucleus. So we see the radioactivity in that case. So source of the radioactivity increase in the number of protons. So in maximum nuclei which are having nucleus are showing the radioactivity. So radioactivity. So if the size of the nucleus is increased, there is a possibility that there is the radioactivity in the nucleus. If we see, there is three type of radioactivity. One is alpha decay. If alpha is coming out from the nucleus, then this is the alpha decay. Second is beta decay. And third one is the gamma decay. Do you know alpha particle? Alpha particle, basically if we see the helium atom, this have two atomic number is 2 and the mass number is 4. If this helium atom, let's consider this helium atom, there is 2 proton and plus 2 neutron and 2 electrons are moving around this. If we remove these 2 electrons from this helium atom, then there is a 2 plus charge comes out. This nucleus is known as alpha particle. This is the alpha particle. So in that case, if we increase the size of the nucleus, there is a possibility of the alpha particle in which 2 proton and 2 neutron, no electrons. इनको तो हमने remove कर दिया ना. We remove that. So there is no electrons, only proton and neutron. But in beta decay, a neutron change into proton and emit an electron. Means in beta decay, neutron change into proton and also a electron is removed. So in that case, when this is the beta decay. In gamma decay, high energy gamma rays without changing its composition. High energy gamma rays comes out from this nucleus. If we see there is the gamma rays, that is the 3 type of radioactivity. In this whole nucleus, we understand how the nucleus is composed, how the nucleus is made up of, what are the composition of the nucleus, and what is the possibility that which force bind the nucleus, and how the electrostatic force give the radioactivity, that is alpha decay, beta decay and gamma decay. Thank you.